welcome to the public library. Thank you for coming in out of the cold tonight, going out into the cold first of all, and coming in here to our cozy community living room. When the rug is out, the living room is in. That's what we say. My name is Pam Packard. I have been hosting this program since pre-COVID. It's a monthly, and the idea of it is just to have somebody from the community come in and talk about something that they know and love or have experienced. Couple housekeeping things. Over there are some surveys up on that short shelf. There's also a list. If you want to be added to our email blast that goes out on Monday that tells you everything that's going on at the library, this one in 4th Street, please put your email on that list. We will get rid of it as soon as we have recorded it. And the surveys, they're just important to help us know how you're learning about things, what you like about things, what you don't like about things. So if you can take a minute at the end of the program to fill out a survey, please do. And I think that's it. I think you're going to talk 30 to 40 minutes, and then there'll be time for discussion. Because again, this is just all about kind of visiting with community members and neighbors. So thanks again for being here. And I give you Gwendolyn or Gwen Waring. Pardon me.
Thanks for coming out. I mean, wow. I were giving a talk and I would be. Anyway, I appreciate it. Let's see. So my 15 minutes here is just going to be on some research that I've done, mostly from early on, early 20s, like that, and onward, and all in Arizona. Let's see, I got to Flagstaff in 1975 from Boulder, Colorado, and had two brothers-in-law who were biologists, and they both worked in Africa, and one on a game reserve, you know, hunting poachers and stuff, and the other worked on zebras in Zimbabwe, I think. And just their stories were amazing, you know, and they'd gone to Texas A&M, and you know, I thought I didn't know where to go. You know, I went to like a billion colleges before I even left Colorado, because when you could afford it, you know, and just didn't know what I wanted to do yet and stuff. So, but anyway, so I met somebody in Boulder. Hello there, who went. These guys all went to Texas A&M, and so I thought I would just go there and finish my undergraduate degree and, you know, see what's what. And then one of the guys I met in Boulder, and he worked at the Museum of Northern Arizona in the 70s, and knew I was really getting to think seriously about going into biology. So he recommended, this was in the museum, was still doing a lot of research, and they had a bunch of programs on the North Rim. And so I got to Flagstaff, heard Navajo for the first time, and just all these, you know, shifts and stuff. And we headed up on the North Rim to do research for most of the summer, which, you know, forget Texas. So I just decided to finish my undergraduate degree at NAU. And it was totally impulsive, totally the way to go. Just this reminder about being impulsive sometimes. Anyway, so I managed as an undergraduate to get involved in some forestry research, studying insects on big ponderosa pines versus in doghair thickets. And it was really interesting. And then I wrapped that up and was going to U of A to do a master's on that. The idea was that I'd be there in the winter and do research up here in the summer, which sounded really good. This was in 79, and anyway, so I got down there, and the funding fell through, which was, you know, those are always special moments. So I ended up, because it's a land grant college, they had a lot of USDA money, and I ended up getting a job working on agaves, which was really awesome. And I just become really interested in ecology at NAU with a guy named, who taught it, Les Balda. That's right. The ornithologist at NAU. And it just was this way of looking at the world and science that really clicked for me. So working on agaves, this seemingly rather simple system, was a great way to explore that interest more. The idea was with this study that we would, I would compare agaves that were cultivated in Tucson, and that's mainly agave americana, although they use a bunch of others too, and then sort of compare their natural history, survivorship, interactions with herbivores, with those with natural populations of agaves, which don't occur in desert floors naturally. They're more upland species. So that's what I did for several years, and it was just absolutely fascinating. In addition to looking at that in town stuff, driving up and looking at the basic relationships of agaves and their principal herbivores was just fascinating. I would drive up to stands in the foothills, like I said, and just wander around these patches of agaves, mainly non-blooming, and could see just what was going on. And this weevil, which I will show another picture of in a minute, is one of their main predators in a way, as an insect. And they fly around and they taste the leaves in plants before they bloom, just assessing their chemistry and stuff. And then, so it's kind of tight in a way. And then once they start to bloom, it's like they've measured this, 60% of the nutrients that are accumulated in the bowl inside, which also makes tequila and stuff. So, but anyway, as soon as the agave begins to send up its stalk, its chemistry totally changes. Its sugars go from being really complex and inaccessible, like try to imagine eating a raw mango versus a ripe one. You know, it's just things turned into fructose or whatever, and just far more accessible. So that happens. The pH of a healthy, non-blooming agave is around 2 or 3. It's like battery acid. So my hands were a mess while I worked on it. And that changes too, so it all shifts, and then it's just this big race to get at resources, because somebody did a cool study. They put a bag with labeled CO2 over an agave and pumped it in, and found that 60% of the carbon is shunted up from the bowl and the leaves to form its inflorescence. So it's this major shift of resources. So they have to be protected. It's like growing for decades, in a vegetative form, and not getting nailed before you get to bloom is kind of a big concern. So anyway, this weevil, the agave weevil, and they're just hysterical, I think. They're about this long and have this tiny little mouth at the end. I can't imagine how that works, but what happens is that they get the signal that a plant's chemistry is changing, and they're like the first one to bore in between the leaves. And with them, we found when I was doing the work, they bring many, many microbes, lots of yeast and other fungi and bacteria. And when I cut open an agave that one might be boring into, it would be going in and there'd be this round sort of circle of necrotic, rotting tissue around it as it went. And then the floodgates open, and everybody follows it in. So it's like a keystone species, which is kind of interesting. And over 40 species of insects and even vertebrates were found to be associated with it. More than 30 in the bowl alone. And sometimes you'd cut into one and, oh my God, it was like a dead body or something. It was just like teeming maggots. It was really, really intense. Lots of flies, of course. But anyway, so incredible thing. And then, the bowl dried out, the leaves, and the action was done there. And then a whole separate suite of insects colonized the stem, including beetles, and also carpenter bees, which you know what those are, the big black fat ones that would lay eggs in the stem and protect them from other animals. And then another bunch of species occurred in the inflorescence too.
About how tall was that one?
Probably 15 feet easy, yeah. And major resource. And a lot of the insects and animals that colonize these guys, it's almost like this floating community in the desert that goes to one plant and then on to the next one. It's kind of fun.
Yeah.
But anyway, this is just another picture. Sorry, these are so tiny of what the weevil looks like. And then you can see there's its mouth. It just seems very improbable that they could, go through tissue that you have to cut with a machete to. Anyway, so that was really fun. I loved that. What else I missed? Oh yeah, no, I think we got it. Anyway, so that was my first project as a master's student at U of A, and I loved it. And while I was doing that, I saw a lot of creosote bush, and noticed more and more frequently that there were all kinds of galls, insect galls, if you know what those are. Galls are really really visible on oak trees. There are many kinds of them, and it's just another way for an insect to eat a plant. Only these are more sophisticated because they actually grow a little house for themselves with associated DNA or whatever. And I found that the nitrogen protein levels in galls were much higher than in ambient tissue, so they really create a world that works for them. And I ultimately found that there were 16 species of gall formers on creosote bush. A number that occur on the leaves, like under or over or whatever, and then furry versus sort of smooth and stuff like that. And then some that occur on flowers and stems, and there's one that's colonial that produces a bunch. The thing that was interesting about them, and I worked with a guy at the National Museum in DC to identify them because all but one were new species, which was exciting. And they're just incredible, and it's what's called, we did an analysis of their relationships, and it is what they call a monophyletic lineage. So they all, like one species colonized creosote bush and then radiated out into all these other species that lived there, which is pretty incredible. And the first one that colonized creosote bush jumped over from four-winged saltbush. And there's a similar lineage of these flies, midges, that occur on that too. So, just to digress a tiny bit, when I was working on this project, Robert Brunig, who was at MNA as the director for a while, and in the 80s, he was the director of the Desert Botanical Museum or Garden or whatever it is in Phoenix. And he asked me to write a popular article on creosote bush for their journal, which is called Agaves. But so I did, and it was just a life changer for me after writing and thinking very analytically about stuff. I found that I just really found my voice, and it was never the same after that. I mean, it's all amazing studying any of it, but I just found that I could speak in a way that really worked better for me. Everybody knows creosote bush, right? It's like the most common plant in our southern deserts, but it originated in South America, and along with a lot of other things migrated up to North America once these two continents came closer in the isthmus actually arose between them, creating a corridor for things to come north, and within the last 3 million years, for things to come north and things to go south. And this is the digression. It's really interesting because one thing that happened with that was what they call the Great American Biotic Interchange. So a lot of species, it's like South America didn't really have many serious predators. And 3 million years ago, we had saber-toothed tigers and, short-faced bears that were, I don't know, cute, just horrific predators, though. So the way it went is that they all went south and cleaned out a lot of the South American fauna. And most of the fauna of South America now is from North America. So it's amazing what's going on out there. But anyway, so Creosote Bush is in all of our deserts now. And some of the plants live to be, oh, okay. I thought I had this in here, but oh, okay, that's just Creosote Bush. This is the colonial gall, which is kind of wild to see. And then this is this guy named Frank Vasic at University of California, Riverside, noted that there are some creosote bushes that the crown in the middle of the plant will split and they begin to sort of move outward into these kind of rings like this. It's all one plant, but just they, moved away from the center. And that one he estimated through a variety of techniques to be about 12,000 years old. So they are some of the old, I hate to say that because who knows, but they're right up there as very old species. And the ones in the Chihuahuan Desert are probably the most related to the ones that came from South America. And then they moved into the Sonoran Desert and their chromosome numbers doubled, and then moved into the Mojave Desert, the harshest of all, and they doubled again. And that doubling of chromosomes, or polyploidy, helps plants and animals to adapt to new conditions like harsher world or whatever. But anyway, see how do we do? All right, so that was pretty cool. I loved that, and I will always be looking at those. But yeah, and the gall formers didn't come from South America. They definitely jumped on ship once the plant got here. I mean, it's amazing to imagine what the deserts must have been like, because it is such a very prominent and dominating feature to a lot of deserts. Anyway, so that was fantastic to work on that. And then I feel like my life ever since has just been this amazing array of stuff. I got to work with the Nature Conservancy on Bebb Willow, which northern Arizona towards the White Mountains is really the southern extent of its limit in North America. It's circumboreal, occurs in Asia too, and migrated down probably with the Pleistocene, the last ice age in the last few million years. And, is very happy at Hart Prairie Preserve. I don't know if you guys have been out there. It's not always easy to get in, which I don't like that. But when they were farming, they had meetings, and I used to go to the Patagonia preserves a lot, where you just stuff money in a box, walk in, and check it out. And they're much tighter here than that. In any event, these plants have done really well, and we studied, and they're worried about them. They want them to thrive, and I think that's a long shot, but why not try? Because the climate is changing. But anyway, they're an upland species, so they need somewhat less water than riverside willows and stuff like that. But we studied them all over the Southwest, and the population at Hart Prairie is amazing. And there are patches in the preserve where they are blooming or reproducing, but it's very rare because there just isn't the water that there was. So right now they're doing a project. They have a wonderful new manager there. They've been aging some of these things, which are very challenging, as you can imagine. None of the stems live that long, and they sort of go in and try to get pores out of some of the middle stems and stuff. And then those have shown to be old enough in age that they're going to be able to carbon-14 date these guys, which is really going to be interesting, because that'll tell us how long they've been here, potentially, which would be really cool to know, when they got to this place. So anyway, that's happening. It's very exciting out there. They have a wonderful new manager, Robert Hoffa, who's just perfect for the job. But
What type of willow did you say?
it's called Bebb Willow, B-E-B-B. And it's, again, an upland willow. And, yeah, from pretty far north, really. So
And are they endangered then?
I don't know that I would say that. I mean, locally, they're hanging in there.
Okay.
And I think figuring out how long-lived they are and all is going to be really interesting for addressing what the future looks like. But I don't know. I mean, the thing about the Pleistocene and change, which is endless, of course, is that things have been moving back and forth, forever. I mean, I love stories like that. Yes. But, with the Pleistocene, they think ponderosa pines weren't here. It was too cold, maybe down in the southern deserts, and then began moving back 10,000 years ago. And dug fir and spruces made it all the way, or way down into Mexico from our northern boreal forests with the cold also. And there are a few new species that arose because of that. I mean, it's just, I don't know how it goes, and I know we don't want to think about change, especially now that it's our fault. But it's a very dynamic world, and it's amazing how quickly things move around. So anyway, that was, it's like aspens are losing range too in their southern latitudes. So it's just the way it goes, and the way it's always gone. I mean, there was a time in maybe the Eocene when there were tropical forests in Alaska. It's fabulous, and that's all in my books, which I did not bring because I walked. So, but anyway, they're great stories. And then, okay. Oh, this is a little out of order, but that's all right. Okay, and then I did some work on Lake Powell, and this isn't Lake Powell, but looking at the shorelines there, and that's a pretty dynamic situation. We actually found we went in the early 90s, and the lake had filled sometime in the 80s, I don't know, a full pool, Lake Powell. And there was this strand line of, mainly tamarisk and a few other things along the river, or along the lake, and amazing, that anything can make it. How they're doing now with it so low, it's a community that will come and go at the cost of everything else. Considered first, but whatever. I mean, I'd never even wanted to go there. You know what I mean? And it was heavy. I mean, we'd go up into these side canyons that were totally inundated, and you could see fields of cottonwoods that were dead. It was just absolutely eerie and just creepy, and felt so wrong, But anyway, it was very interesting study. A lot of animals associated with those plants. All right, and then I got to work with the Nature Conservancy on the San Juan River, which was a real treat. And this is, as it's getting ready to go into the canyon there. But looking at the relationships of native and non-native riparian plants. And San Juan is in better shape than a lot of rivers. There's still a lot of sediment that makes its way down the corridor, which is a big deal for plants to be, have the nutrients available. But we looked at native plants, cottonwoods, and coyote willow, which is a clonal willow, very widespread, probably throughout North America, I guess. And compared their insect loads with those of non-native plants, i.e. tamarisk and Russian olive. And it wasn't, of course, as simple as you might think it would be. I mean, the logic is always that native plants will have a greater array of animals associated with them because they've been in place and relationships have evolved. So, coyote willow, which is probably the main thing along some of this native, very rapidly growing willow species, had the greatest numbers of species and numbers of insects. So the native, and then cottonwood was slightly less, although we realized we were sampling their lower canopies for insects, and it's probably up in the top of their canopies where it's sunny and stuff that the real insect action occurs. So that one. But then tamarisk had almost as many insects on it as cottonwood. And then, of course, the low one was Russian olive, which hardly had anything associated with it. And that plant is troubling. Are you guys all familiar with it, Russian olive? Introduced a long time ago, like tamarisk, for bank stabilization, wind breaks, Midwest and stuff like that. But it's really bad news. Very little is associated with it in terms of animals, and it's just built to succeed on a dammed river. It's nitrogen fixing for one thing, so it can come up under the shade of native things and shoot over them and just take up more and more space while offering very few resources. So it sucks, It just really does, and we'll see how it all goes. Who knows? I guess with tamarisk, they did introduce a leaf chewing beetle that has really sort of cleaned it out in some areas. And I've seen a lot of that on the San Juan too. But anyway, wow, that's an amazing river to go and get to. Coyote willow is doing really well. Okay, and then from the San Juan, I got to go. Oh yeah, this was another thing we found during the study, is that the amount of vegetation that occurs along the shoreline in southwestern rivers is very dependent on what kind of rock the river is actually cutting through. So this is one of the lower limestone canyons on the lower San Juan. You can see it's pretty steep and straight, not much in the way of clay, and where the channel can go. It's tight, and it really restricts vegetation and just the movement of the river laterally. This is in the upper San Juan near Flagstaff, and this is in sandstone. You can see the difference, right? This is the river proper, and this is the floodplain that it's probably gone back and forth over for a gazillion years. And this is the vegetation. Wonderful sort of bosques of cottonwoods and willows. That was kind of fun to see that. And the next study that I got to do was with the Bureau of Reclamation, and then that became the Department of Interior, I guess. But my question was, what did the river look like before the dam with regards to riparian plants? What did the river look like before the river was dammed versus after? And so I was able to compile I think 5 sets of aerial photographs, and it was really interesting. You know, these things are like a window into another world. But so what happened was that before the let me do this right. Hold on. Referring to Lake Powell too. So they were both obviously affected by Glen Canyon Dam. Okay. All right. Okay, when the gates closed in the 60s, 62, there was a lot of riparian vegetation along Glen Canyon, or through Glen Canyon. Now that is a sandstone section that the Colorado River passes through. Its grade is pretty flat or low, and meanders like mad all over the place. Of course, I don't have a picture of that. But as a result of that circumstance, just like with the floodplain stuff, a lot more plants could live there. So even though the Colorado would flood every year, or most years, and none of it was dammed, the floodwaters as they moved through Glen Canyon would be slowed down by its, movement and its flatness. And then when they hit the Colorado River in Grand Canyon, which is mainly limestone, or schist and stuff, that river is much straighter by and large, and the angle of its course is much steeper. So with each spring, everything along Glen Canyon would just be like la la, and then everything from Grand Canyon would just be blown out every year by these horrific floods, even though upstream it was more moderated. Very curious. So anyway, when the river was dammed, so there was very little vegetation along the Colorado River and Grand Canyon before it was dammed. Stuff just got blown out every year, or most years. And once the river was dammed, obviously everything in Glen Canyon was inundated, and that's history. But on the Colorado River, in the canyon, vegetation increased by more than 100% along the river because everything was stabilized all of a sudden. They kept the water levels really low as the lake was filling behind the dam, so the days of big floods were over, at least for a while. So just, huge expanses of vegetation, including clonal things like coyote willow, which might, in a flood year before the dam, be cleaned out up to the back of a side of a canyon wall, and then being clonal, they were able to kind of grow back to the river. But, so night and day there. Does that make sense? I mean, it's amazing what we do. But anyway, so that's the way that went. And then like more than 100% increase in vegetation, although the big floods in the 80s when the lake did fill. Do you remember that, any of you? Wow, it was crazy. They thought the dam was going to blow. It was like just some huge high water years in the 80s, weather-wise. And anyway, so they had to let a lot of water out of the floodgates or they were going to lose the dam. I mean, they were putting plywood over the top of it and stuff, which sounds kind of weird. But anyway, in the process of doing that, they destroyed a lot of the through channels of the dam, costing millions of dollars in damage. But that resulted in some flooding that was around 100,000 CFS in the early 80s, which is a big, big flood. And that knocked the vegetation back by about 20% from its new increase. But overall, it has increased a lot. It's a really complicated system. With the dam in place, there's no more sedimentation going on. It's a losing system, So, but God, it was really interesting. It was really fun. Ooh, okay. This time I'm done. Okay, Gooding Willow. Oh yeah, one of the willows I studied, Gooding Willow. Oh, okay. That's just to show how the flooding went. So there was a beach, and the 100,000 CFS came in and, totally inundated all of that. And then when that receded, a new beach, and then it all started again. It was pretty turbulent. And a lot of the sediment that was in the drainage, that was in the Colorado in Grand Canyon, made its way down to Lake Mead, and that's what all this red stuff is. And that was amazing. A lot of riparian plants migrated down there, and there were, you know, riding through on a boat, these just expanses of willows and cattails, and just incredible riparian habitat for as far as you can see. Just unprecedented. And it's an incredible resource for insects and birds when plants are growing in good nutrients, a lot of water. And so Gooding willow, which grew in the canyon at protected places, a tree willow, ultimately moved down to the lake too. But anyway, enough on that. Okay, and then what else? Oh, right. I was hired to do, when they expanded 89 going north, they wanted to do a lot of studies in the area because there are a lot of Native American woods and stuff. And the company that got the contract for that, Desert Archaeology out of Tucson, was amazing. This guy was a real scientist and not just a mitigator, you know, just get it out of the way and let's build the road. So anyway, they hired me to do a project because there were a lot of people in Wupatki at times, you know, in the last few thousand years, even just unimaginable densities of people. And a lot of evidence of agriculture. So they hired me to grow. I got a hold of Hopi corn, which is, the kernels are huge and have a really long primary cotyledon. So the seeds can be buried deeply and still make it all the way up to the light, you know. And that's why when you're driving on the res in summer and you see corn coming up in fields that are obviously not getting, you know, watered at all. It's like what happens is, and we did this too here, but in the year 2000, I figured we'd get nothing because that was really dry, but we did a series of experiments growing the corn at different depths and then putting different depths of cinders over them because they feel like those were used in agriculture too. And sure enough, in a super dry year, I didn't think we'd get anything. But stuff did start coming up, particularly when it was covered with cinders. And that was going off, and that's before monsoons even hit. And that was going off residual winter moisture in the soil, which is really what the trick is. You get it started, there's moisture from the winter, and then monsoons come. So it's kind of cool. But anyway, so it actually worked. And I mean, not well, we didn't get any corn cobs or anything, but it was just a really great indication of how that works and how brilliant it is, really. I got to work in the Mojave. This was one of my favorite projects on rare plants and tortoises. Those are the best times I've had, I think, in field work. Just working with a crew is great. You get up at 4 in the morning and walk these plots looking for these little annuals that were just so tiny and beautiful and stuff. It's really fun out there, you know, to just do all the junk you can. And then I wrote a couple books. This one first, which is I love that book. It was funded by the Arboretum to a degree, and got a pretty good grant to start with. And the last chapter in it was all about wildflowers that we all know. Like there's a section on penstemons and paintbrush, and buckwheats, and stuff like that. And their stories are you would really like that as a docent,
I'll
They're
have to
just-
see if we have a few in our collection.
I certainly hope
think
so.
we
If
do,
not, I
yes.
will bring
Okay.
one over. But that was amazing. And on that, I wrote the flower chapter last because I knew by the time I got there, I'd just be so sick of the whole thing. I mean, they're 5-year projects, you know. So, and it's a privilege initially to wake up and think, okay, what are we going to learn about today? Anyway, so that's a fun book. And then this one, of course, I got somehow, you know, Giovanni family, Geofund were incredible and others. It was really, really fun to write about. And now I'm painting.
Awesome.
Oh, and actually, I continue periodically to write this column called Nature Notes, which started with this one in 2012, God, 20 years ago. And it was just kind of a lark, you know, just I love natural history. And I, you know, every year the pine pollen is like crazy and stuff, you know, just coating everything. And then, so that was going off, and then it was a big cicada year too. So it was really fun to research those. We have more than 30 species of cicadas in Arizona. But and I love the paper actually decided on the title, which I thought was adorable. Anyway, I'm going to make a book out of these. I've got like 50 articles, and they're all like that. It's local stuff, a lot about Buffalo Park. So, and painting. That's all I have. Anyway, it's all I've got.
What kind of painting are you doing?
I posted one and I didn't. I really love our landscapes. And I find them endlessly moving. And I think my experience with working on species somehow informs that, although I don't understand how and whatever. But anyway, so that's what I'm doing. And I have a few articles, if anybody wants to take anything, just things that I have available on my business card. And
Does anybody have any questions?
Oh, yeah. Questions, comments? You look so familiar. Okay, maybe.
So my question's kind of selfish, but
Good.
I work on Leary's local town.
I'm sorry?
I work on a Leary's lab up there. And
Oh, right, okay.
I just am wondering if you've had any like experiences out there or any special insight to that general area.
I've done several artist in residence things in Wupatki. I've worked a lot in Wupatki.
Okay.
Is that? We could meet for coffee or something.
Oh, yeah.
But
I just was wondering if you had like,
I was amazed with the fire, how much that nailed the
yeah.
base of O'Leary.
Yep, the whole, it went all the way up and around.
Really?
Yeah. The south face is more of a mosaic, but the north face is.
You weren't out there then.
I had to leave.
Yeah. Boy, that must have been.
But I got back up there and, but yeah, it was horrible. Like, I mean, I don't live at Noe Park or anything. Just
Yeah.
being so, like having a relationship with that land.
Right.
It's just-
Yeah, you know, there are so many dead stands or stands of dead junipers out there. I
That's been
figured,
crazy the last
whoa.
couple of years.
It sounds like it didn't hit those. That would have been
No, I
really,
expected
but it was
it to just-
close, yeah. But I'm not sure exactly what you're asking or what
No,
you're
I mean,
wondering
like,
about.
if you've done any research in the area, aside from you were talking about
The artist stuff, yeah.
and the 89 highway.
Right.
Yeah, I didn't know.
And Dead Man's Wash is pretty amazing.
I've heard that.
That goes, I don't have a picture of that, of course, but that goes, it actually starts on the northwest side of the peaks in Hochdorfer Hills, and then goes down, okay, so, all right, so there's the peaks, here's Hochdorfer, this is north, And the Dead Man's Wash goes along the north base of the peaks, and everything drained into it at the end of the Pleistocene, and all the way to the Little Colorado from there. And there are great places to see it all the way through Wupatki, but it appears, according to Richard Herford, this geomorphologist friend of mine, who would be great to have talk here, but a lot of the lavas, basalt that was, brought to the Little Colorado River was from the inner basin, which was cool when the glaciers there were melting. And, I think that's kind of neat, just how things work. But I'd be glad to talk to you more sometime, or even come visit you.
Yeah, come on up. I'll be back with
Really? Wow, I should get your contact
Yeah.
stuff, because I would love that. But yeah, I'm not coming to any great.
Yeah, no worries. I figured I'd throw it out there.
I mean, there are a lot of weird plants and stuff. I did one article on Wupatki, Nature Notes, and the plants there are really weird. A lot of endemism, things that occur nowhere else, and just really, really nice and strange. But I'll get your name and contact, and I'll think about it. Okay. Anyway, well, thanks. Oh, yes, ma'am.
When you were talking about your work in the Mojave Desert, and you said you worked with bird plants, are you saying tortoises?
Yes, I did work with.
Yeah, tell us about it.
I didn't do as much of that as some people, but it was pretty interesting. I mean, a lot of this was driven by, it was during the Obama administration, and there was stimulus money to get some big solar plants going in the Mojave. And so that was like a mixed bag, because there was some pretty amazing desert that was going to get carved up for that. But so, the surveys were exhaustive, and a lot of tortoises ended up being relocated, which doesn't necessarily work all that well. So I really, I suppose we all facilitated the development, but I had a hard time with that. And I'm more of a plant person anyway. But yeah, the tortoises, many were relocated. They were amazing to watch, though. A lot of them ended up being have tags and monitor, the ability to monitor them and all. But like during spring when the opuntias had bloomed, they'd produce dark red fruits, and the tortoises loved those, and would eat them, and always had like this lipstick.
Aw.
That was cute, but
Did you say the survey was before a road went in? Or what?
no, we're talking solar plants.
Oh,
Yeah, power plants for solar.
oh,
And California's really done a lot of that, believe it or not. So, but yeah, it was a mixed bag in ways, because solar's great, obviously, but like we want it on everybody's houses, right, instead of in these beautiful places. But it was extraordinary to see these plants, and the money was unreal. But anyway, did that help?
oh, very much, thank you.
Okay, sure. Well, thank you for coming
Oh, thank you.
very much.
Gwen.
Really
Yeah.
nice to, I must say, I think everybody should sit down and sort of map out the last billion years of their lives, and what it means, or doesn't mean, or it's pretty fun, really, see where you've come and stuff like that.
Well, I am so glad that you wanted to join us and tell us some of your story. And
Thank you.
I always ask when you fill out the survey, if you know of somebody who should be up here, or if you want to, please put your name down and I'll contact you. There's all sorts of stories to be told.
Yeah.
And the subject matter here is all over the place. So, yeah, we've, musicians and ecologists and haunted Flagstaff, just so many different things we've done.
So how do we find out about the schedule?
So one of the best ways to find out about what goes on here is to put your name on the email list over there. And then you'll get an email every Monday that tells you everything that's going on that week at the library.
Oh, okay.
And we have so much going on these days. And then, and we also, we have flyers around the library, plus we try and get everything in the Daily Sun and KNAU's event calendar, Flagstaff 365's event calendar. So we try and
Okay.
get the word out there. Word of mouth works the best.
Okay.
And we have our social media outlets too, Facebook and Instagram.
Right.
So, but that email blast is the best way.
Yeah, look
So,
for that.
So,
Thanks. It
well,
was nice.
thank you. And thank you all for coming out on this very chilly evening.